Very often in mathematics, we deal with the geometric form of vectors. Look at this. This could be a vector PQ, which could also be written as, let's say, vector B. Yeah. B has two kind of information hidden inside it. This B vector has the component of the magnitude and the component of direction. Hence, it is a vector quantity. But how to find the pure magnitude? To find the magnitude, we actually do the modulus of B. Alright, this is just the magnitude. And mod of B has no component of direction. This is something we should be aware of before moving forward. Look at this vector. Okay, I'm calling it vector A, and this one I'm calling this vector B. Do you think there is any connection between A and B? And here I have another vector C, and yet another one, vector D. If you look carefully, all of them are in same direction. They're all going from west to east. So one thing can be concluded very confidently, that vector A is parallel to vector B, which is in parallel with vector C, and finally all the four vectors including D are parallel to each other. That's a very clear cut information. Now look at the magnitude. Because the length of the line segment represents the magnitude of the vectors, A is taking 2 blocks in this graphical picture and B is taking 4 blocks. So I can say that B vector is double of A vector. Alright, this information means that the equality tells you that the vectors are parallel to each other, and the component 2, the coefficient 2, tells you that twice of vector A will be equal to the B vector, which is clear geometrically also. That's one relationship. If we talk about vector A and vector C, so vector C may be ahead, looking to be ahead of vector A, but that does not matter. Ahead or behind or on different planes does not matter, as long as they are parallel to each other and as long as their magnitudes are matching. So you can say confidently that vector A is equal to vector C. They're both equal vectors. And if we talk about D, evidently D seems to be half of A. We can say that D vector is half of A vector. This is how we create relationships between parallel vectors. What would you say if I had another vector, which I'm creating right now, however going in the other direction, going from east to west, and with the name E? We'll say confidently that A and E have a connection. They are negatives of each other. So this vector E is nothing but the negative of the A vector. Alright, so we should have a knowledge of negative of a vector and parallel vectors, equal vectors. Everything is taken care of in this little discussion. Now tell me something. Let's say a person started from point A, went 20 meters towards east to a point B, and after some time came back to A, covering the same straight line. So what's the final displacement of this person who started from A? You will say that the displacement is 0. Though the distance traveled by the person was 40 meters. Am I right? He actually walked 20 meters front than 20 meters back. Distance takes care of that information. But displacement is about where were you initially and where are you finally. So there's no movement actually. Okay. So we say that displacement is zero, but how do I assign a direction to this? That can become a challenge. If I'm claiming that displacement is a vector, how do I assign a direction to this zero displacement? So we will say that displacement is zero with a direction random. We can say that yeah, this also has a direction, and we can give any random direction to this displacement. You could say that displacement is in this direction or in this direction or in this direction. So 0 is open to be used further. From here the story can go in any direction. That's why I'm saying that the direction is random. So 0 can be displacement and it will have a direction which is random. This gives rise to a vector fact of zero vector. So zero vector has two things. The magnitude is zero and the direction is not defined or random. Not defined, by not defined I mean not clearly defined. Alright, sometimes we write the zero vector as O with arrow. It could be a small o with arrow. This is the representation of zero vector. Yeah. Okay, let's look at a situation. We have a parallelogram treat it like a parallelogram only. ABCD. If it's a parallelogram, AB will be parallel to DC and AD will be parallel to BC. If I told you that the magnitude of AB is represented by small a, the vector itself is small a vector, and the AD is small b vector. So we can confidently say that DC will also be a vector and BC will be the b vector. So that's an advantage of having some knowledge of basic information, and based on that some more information can be created. Let's say I have to add two vectors. I have got a vector small a here and a vector small b here. How do I add these two vectors? What do you think? Okay, think about this.